Okay, welcome to the video on graphing linear inequalities. Before we begin, it's important that you know how to graph linear equations, because this skill builds upon those skills. To graph a linear inequality, you just pretend it's a linear equation and plot your points. Now, it's not a linear equation, it's a linear inequality, but it may include an equal sign. So if your inequality symbol includes the equal sign, then we will actually use a solid line. Just as we did when we graphed linear equations, we used solid lines to graph lines, to graph linear equations. So if that equal to sign is there, you're going to have a solid line. But if the equal to sign is not there, if there's just a less than symbol or a greater than symbol, then we're going to use a dashed line. In this case, these points are not included. This is called boundary not included. So we're going to have a dashed line, which is technically not part of the actual graph. Lastly, we need to know where to shade. So if our inequality looks like y is greater than or equal to the line we just graphed, in other words, y, the up or down value, is bigger than the line, we're going to shade above the line. Y is bigger than the line, we shade above the line. Likewise, if y is less than the line, or y is less than or equal to the line, we shade below. Y is less than the line, we're going to shade in the y direction, we're going to shade below. Y is smaller. Let's try a couple examples. So here we have a very straightforward linear inequality. Please notice there is an equal to sign here, so we're going to have a solid line. But I'm getting ahead of myself. Let's graph this first. My y-intercept is -3, 1, 2, 3. So I plot my first point here. My slope is -2/1, or rise -2, run 1. So I go down 2, run 1. I'm running out of room, so I can also go rise 2, run -1. Rise 2, run -1. Rise 2, run -1. Rise 2, run -1. You get the idea. So I've plotted the points as if I were graphing a linear equation, but it's not. So I look at the inequality symbol. Is there an equal to sign there? In this case, there is. So I'm actually going to have a solid line. I should have used a straight edge. Solid line. But now I need to ask myself, am I going to be shading above the line or below the line? In this case, it says y is greater than. So in other words, the shaded values are going to be bigger than the line. Y is bigger than the line. So I'm going to go above the line. So I'm going to shade up here. Now you may be asking yourself, what about this region? I don't see my line anymore. Do I shade over here? And the answer is yes, because technically the line goes infinitely down here. Even though my graph paper ends, the line does not. So technically, this entire region of the graph is shaded. Let's try another example. We're going to start by taking a look at the y-intercept. We're going to pretend this is a linear equation. The y-intercept here is -1, and my slope is 2/3. Rise 2, run 3. Rise 2, run 3. Off the graph a little bit. Then I can go backwards. Again, rise -2, run -3 accomplishes the same thing. Rise -2, run -3. In other words, run 3 spaces to the left. Rise -2, run -3. Now, do I just draw a line through these points? I need to ask myself, is there an equal to sign here? And there is not. There is no equal to, so I'm not going to draw a solid line. I'm going to draw a dashed line. This is called boundary not included. This line is not technically part of my graph. And now, where am I going to shade? Am I going to shade above the line, or am I going to shade below? Again, I look at what the inequality is telling me. Y, the shaded portion, is less than the line I just graphed. Y is less than the line. Shade less than the line. Shade below the line. The y-axis, I'm going to shade in the negative direction. I'm going to shade values that are less than this line that I've graphed. So my shading will look like that.